So let's start, guys. In the last lecture, last two lectures, perhaps, we learn about plottings and graphics. Previous to that ones, we also learned how do we solve the ordinary differential equation of first order, where those are IVPs, initial value problems. And we also saw how the flow of information takes place when we write the ordinary differential equations. So basically, we need at least two files. One is a script file, another is a function file. In function files, we do write the ordinary differential equations, and in script file, we do call the ordinary that function files with ODE solvers. There are many ODE solvers like ODE 45, ODE 23, ODE 23DB, so and so forth. So the first we in general uses ODE 45. If the problem at hand is stiff, then we can go with ODE 15S as the second type. If that ODE 15S does not solve the problems, then we can go with the other solver. These solvers are basically the methods which has been coded in a function files for solution of any particular order differential equation. So for example, ODE 45 is basically based on Rangakutta 45 methods. So we saw in previous lecture how do we solve one equation. If we have only one differential equation, then how do we solve it? Now, basically, the order differential equations come across when we are going to model any systems where there are changes with the independent variables. And if the changes are only with one independent variables, we end up with order differential equations. And we know that if the changes are with two independent variables, then we end up with partial differential equations. So any system which we model and where we wanted to see the changes with the dependent variables, we end up with ordinary differential equation. And we saw how do we solve one ordinary differential equation. But in practical situations, we never get one ordinary differential equations for a system. When we model a complex systems, we might get n number of ordinary differential equations. Then how do we solve the more than one ordinary differential equations or n ordinary differential equations in Matlab? So today we are going to see those things. So if you have two equations, let me start my Matlab. If you have more than one ordinary differential equation, the slight difference in a solution. So what is the difference? A difference in writing the function file. So if you remember the last times we wrote the function file for one ordinary differential equation, the same way we can write the function files, but a slight difference. What is the difference? So the functions and its outputs, then the function file name, and then input argument and state dependent variable or state variables. Now we have two ordinary differential equations. For example, dCA by dt and dm by dt. Now the state variable here are Ca and m. Correct. So now there are two ordinary differential equations. You have two initial conditions that like Ca at time t is equal to 0, what's the value, or m at time t is equal to 0, what's the value. But in Matlab, we treat this Ca or m as one variables, okay, as one variables, and that variable here in this file is designated by x. Now x has two elements because we have two ordinary differential equations. So the first element is indicated by x of 1 and the second element is indicated by x of 2. In this case, if we have dCA by dt and dm by dt as two ordinary differential equation, then Ca at t will be the first element, that is x of 1, and m at t is equal to 0 will be the second element. When we write differential equations, we should write in this sequence. So the first differential equations will be of dca by dt. The second differential equations will be of dm by dt. This is the first change when we go from one ordinary differential equation to the second ordinary, more than one ordinary differential equations. Okay, so the x, which is a state variables, now becomes vector. Vector of elements equal to number of differential equations. Okay, and the second important change is that as our output is ds dt, we write ds dt of 1, where we will going to write the first differential equations, and then ds dt of 2, we will write the second differential equation. If there are 3, then ds by dt of 3, we will write the third differential equation. That's the second change. Now the third important change in writing one differential equations, we straightforwardly went and wrote the differential equations. But here, when we are dealing with more than one differential equations, we need to explicitly tell MATLAB that now you have more than one differential equation, so that while solutions or while solving this differential equation, you should reserve the space for this differential equation. To reserve the space for this differential equation, we need to tell MATLAB that there are how many differential equations coming to. So this has been done by writing this statement. DSDT output is equal to zeros, number of differential equation, comma 1. So once he encounter this statement, he understands that there are so many differential equations. I need to reserve the space for that one, and that's what he exactly does. So for that purpose, we should be in a position to tell MATLAB that these many differential equations we are going to solve. Correct? So we need to write a statement like ds dt is equal to zeros of number of differential equations, comma 1. So these are three important changes. These are three important changes need to be incorporated when we are going from solution of one differential equations to more than one differential equations. I hope this is clear. If you have any problems on what I said right now, please let me know. So let's code these differential equations. So I'm changing the directory of my MATLAB. You also code simultaneously. I'm changing the directory of my MATLAB, making it class 21. And then I will first have a script file, m file, where I will write first clear all CLC. And then I need to provide time span. I can write T span as 0 to 100. That's what the time span I'm going to say. And now I need to have initial conditions. I have two differential equations. So I have two initial conditions, which I'm right now here writing as x0 is equal to, first, as let's say dca by dt. So ca at t is equal to 0 is 3, and dm by dt, so m at t is equal to 0 is also 3. So I'm going to solve this. So I got this. Then I want t comma y as output. ODE45, that's a solver at the rate of file name. File name is, I can use 2 ODE. Then I need to write t span, and then I need to give initial conditions. This is what is the syntax. Okay, now we know how to plot, so I am going to plot it. Plot t comma y. Let's say plot first y. Or I know I am solving two differential equations, so y is now vector. Earlier it was also vector, but it was having one column. Now it will have two columns. First columns will give the solution of first differential equation. Second column will give the solution of second differential equation. So all the rows first column. And then I know how to plot the second one. So I can write plot t comma y of all the rows second column with, let's say I am plotting it in a red color. So this is what I already learned. So I have my differential equations script file. So I can write script script for 2ODE. Then I'm going to write function files. I know how to write a function file. So function output, let's say I can write dy dt as my output is equal to function file name, which is I given 2ODE. So it's a 2 underscore ODE. Input argument, independent variables and dependent variables. I have dependent variable as x. Then I need to tell Matlab that this file has two differential equations. I told Matlab this file has two differential equations, and then I can write first dy dt of 1 as equal to, what is differential equations? It's 3 sine t. So it's a 3 multiplied by sine of t, independent variables. And then dy dt of 2 is equal to 4 into cos of t. This is what the differential equations. I wrote these files and I am going to save it. Then I am going to run it. So look at this. These are the files, solutions. I can give on X label as time in seconds, my Y label as as trigonometric functions, and I need to provide legends. So first legend is sine, second legend is cos. Again, I will run it. I can give a close or also. So look at this, having X label, Y label, and legends. I can even give title, which I just wanted to provide you the recap of this. Okay. Now I just wanted you to show the workspace. Look at this, this solution T and Y. So let's open the Y. So Y is at this point of time is basically a two column n number of rows matrices. So the first is a solution of dCA by dt, for example, and second is the solution of dm by dt. Or here we have 3 sine t is the solution of this, and 4 cos t is the solution of this. If we have 3 differential equations, one more row is going to add. Now, if I wanted to save the data which came here, so I can create the data. I will concatenate the matrices, that's a t and y. Okay, and then I can say save 42 data with the data as a variables. See the data, OD2 data file has been created. Okay. So anyone has any problems on this ones, please let me know.
Hello, sir.
Yes.
Sir, in the plot function, in the script file,
Yeah.
in the script file, in that plot function, we use t comma y. Then, yeah, t comma y semicolon one. What happened with that semicolon and one?
Actually, y is see, we are solving two differential equations. Correct.
Yes.
Y is n number of rows with two columns.
Y is.
Agree?
Just a second, sir.
So now I wanted to plot the first one. So colon basically indicates all the rows because colon is at rows place.
Okay. Yes, sir.
All the rows, and one indicates that the first column.
So y is denoting the output of both the two, but in different rows, different columns.
Yes.
Okay. Yes, sir. Got it.
Any other questions?
Excuse me, sir.
Yeah.
So I'm getting an error that execution of script plot as a function is not supported and the graph is not coming.
Share your screen.
Yes, sir. So is it visible?
So look at your file folders where there might be a file named as plot you created. Look at your folder.
Yes, sir. Yes, sir, it is there.
Yeah, delete that. And I told you to create a folder. See, if such a problems arises in examinations, it's very difficult. So don't mess up with Matlab's own directory. Create another folder and put your all files.
Okay, sir.
Now run this.
Okay, sir.
Anyone has any other problems, questions? Okay, if not, let's move ahead. Now I want you to solve these differential equations. Correct? It has two differential equations with two initial conditions. Take the time spans from 0 to 10 and try to solve this. I will provide you 5 to 7 minutes and then I will ask to share your screens. Pratish, can you share your screen if completed?
Not completed, sir. Like, I can still share it.
Okay. I will wait then 2 minutes.
Yes, sir.
Tirtha, have you finished?
Hello, am I audible, sir?
Yeah,
I'm still doing the function file.
you're still doing the function. Who has finished? Is there anyone?
Sir, I'm getting an error.
Error you are getting. Show the screen.
Yes, sir.
You understood the error?
A little bit of it, I'm getting it.
Go up on the first line of error. So you see your function name is CLQ clock OD underscore S, and here you are not written yes.
So this is the function.
Then
The name is
you did not. So here the name is different. CLQUE1 is required.
okay, okay, yes. And here also I should change this thing.
Again there is error. Go to the first line of error. Go to your function now. dy dt 0 to 1, that's correct. Dy dt of 1 is dy dt of 2. Why do you wrote dy dt 2?
So because there it is y2 written.
Yeah, so write y2 na, straightforward.
Okay, sir. This will work?
Not no, it's see, you people need to understand. Now there are two differential equations. Those initial condition will come into y, correct?
Yes, sir.
Now you wanted to access the second element of y. I will write y of 2. Yeah, this will give you second element.
Okay, sir. So I
Then
need to change
you need to
accordingly.
write dy dt of 2 here on the second line, fourth line number 4 first.
Yes, sir.
So there 2, correct? You understand why you are writing this?
Yes, sir.
Now
Yes,
you
sir.
are writing the second differential equations.
Yes, sir. This way,
Now
sir?
you save it and run it.
Yes, sir. It worked.
Plot everything. Now Tirtha finished. YL Pratish
Sorry, sir?
YL on line number 6 plot.
Yes, sir.
After that what you wrote?
T, comma Y.
It's a T or L.
T, sir. T. This is T.
Okay. Okay. Done. Abhijit Abhijit Meshram 1970.
Yes, sir.
Finished Abhijit?
Sir, no, sir. Actually, no, sir.
What's happening?
Initially, I got some error. Then, after I see the Turkish file, then I'm changing something.
Okay. Lotake Aryan. Then you solved it, correct? Aryan. Oh, it's all like this. It's coming like this way. Huh? Can you show the function file? No, I really don't know whether solution comes like this way. Fine. Can you reduce the time horizons? Make it 1. Time horizons in your script file. Make it 1. Now simulate. Okay. Yeah. Fine. So solution might be like this. I don't know. Okay. Good. Okay. Is anyone wanted to share his or her screen, or the people who are facing problems? Don't hide your problems. Okay? If you are not understood, it's very difficult to code. If you are not understood, it's very difficult to code. So understanding is very important. Ash Dhaki. Ash, can you show your screen?
Yes, sir. 2 minutes. So is it visible?
Yes. Can you run it? Oh, you are getting like this way?
So I have taken T-span means
Oh,
0.01.
0.01. 0.01. Okay, fine. Fine. So see, the plot is not, I mean, blue color plot is not visible. So what do you do? What is the option?
So,
Yes, what is the options? Visualize this.
uh,
Go to subplot. Yes. You know subplot, we learned yesterday subplot. No. Go to the code and write a subplot. You know, yesterday we saw subplot.
not remembering.
Huh?
Sir, I'm not remembering that.
Sorry?
So the code, sir, I know yesterday means subplot was taken, but I'm not remembering the code.
You was not there in yesterday?
So I was there.
Okay, learn the subplot.
How do I don't know.
Tirtha finished? Tirtha Binchurka.
Yes, sir. I'm getting error.
Yeah, show the screen. I am here to solve the error only.
Okay, sir.
Go to the first line of error. Invalid expression when calling a function or indexing variables. Use parentheses, otherwise check for mismatch delimits. Okay, so where it is on OD13 fun. Yes, there is error. Click. Line number 3. Line number 3. No, zeros is correct. ZEROS. Remove the E. And now you need to have parenthesis, not the square bracket. Run it. Okay, go to the first line. It has again some errors. Invalid. Now go to the first line of here. Invalid expression when calling a function indexing a variables. Use parenthesis. Otherwise, check line number 5. Now error is on line number 5. Here in functions. Read the error, Tirtha, loudly for me. Read. Read the first line of error loudly. First line of error.
Invalid expression when
No.
calling a
Before that. First line of error.
file OD13 underscore fun line 5 column 14.
What you
So
understood?
here.
There. Okay.
Okay, there are again many errors.
Yeah. So unrecognized function or variable x0.
But I've already like have
Go
that
one
in
by
the
one. Yeah,
script.
run it. Don't worry. Save it and run it. Again go. Doesn't matter. Unrecognized function or variable x0.
So it's
Where?
already there in the script file.
Yeah. Hold on. Don't worry. It says unrecognized function or variable x0. Where it says error in ODE 13 underscore fun line number
Yeah.
4.
Line number 4.
Line number 4. So you wrote something. So now here, see, in your script file, you wrote x0, correct?
Yes.
But in your function file, that input argument is designated by which variable? X0 or x?
X. Okay, okay. Yes. So I need to put an X here. Okay, I just
Yeah. So now you see you are not able to see it. Reduce the time horizon. Make it 0.1.
okay. Time
Yeah. So this your
horizon as
iteration
in.
value.
Sir, I didn't get you.
Your iteration value.
Okay.
0.1. Run it. See, you first you close this live sessions. Close.
Yes.
Okay. Now you see. Now see the was you yesterday there in the class?
Yes, sir.
Okay. Now look at this. The problem here is that the blue color data is not clearly visible. Correct?
Yeah, it is showing a straight line.
So what we should do now? What is the solution for this? So there is no problem in solution of the ordinary differential equation. There is a problem in visualization. Agree?
Yes, sir.
So what you do? The solution is you plot the subplot.
Subplot.
Yeah.
Okay.
You know, yesterday we learned the subplot.
Yes, sir. Sir, but I didn't practice it much.
No, that's your problem, correct?
Yes,
My
sir.
job is to explain the things. Your job is practice. If you have time, practice. If you don't have time, don't practice. Let's look Lihas. Lihas, can you share your screen? Lihas.
Yes, sir.
Yeah. Who is this BT 1900? Lihas, share your screen.